Support reactions will be developed according to support conditions. You are about to watch different support conditions and the variations in the reactions developed. Support conditions influence the resultant motion of the system as well. The animated explanations with practical examples will be helpful in understanding support condition idealizations like pin supports, roller supports, etc. So keep watching. As per Newton's third law, for every action there will be an equal and opposite reaction. A vessel resting on a surface is applying a force equal to the self-weight of the same. As the system is in equilibrium, the surface must be applying an equal and opposite force on the vessel, and the same is called reaction. An interesting property of reaction force is that it is self-adjusting as per the applied loads. If the vessel is being filled with water, the net weight of the vessel goes up, and to keep the system in equilibrium, the reaction force increases accordingly. Now consider a metal ball hung by a chain. Again, the force acting is the self-weight of the ball, and an equal and opposite reaction is offered by the chain as the tension develops. In case the metal ball is getting heavier, the tension in the chain increases and keeps the system in equilibrium. However, when the weight of the ball increases beyond the capacity of the chain, the ball will find equilibrium somewhere else. Consider a container being filled with balls. Balls already in the container will get affected by the new ones, but finally comes to an equilibrium condition. Force or reaction will be transferred through the surfaces in contact. Action and reaction will be acting perpendicular to the contact surfaces. Please note that this is true with an assumption of frictionless smooth contact surfaces. Let us analyze the bottommost ball. The self-weight of the ball is acting at the geometrical center. Additionally, the balls above will be transferring a component of the self-weight. These loads will be acting at the point of contact and perpendicular to the contact surfaces. Support reactions will be developed at the contact surfaces of the container. At the bottom surface, the reaction will be vertical, and at the inclined faces, the reaction will be perpendicular to the surface at the contact location. So, under the action of these forces and reactions, the bottommost ball is adequately supported and the same is in equilibrium. Support conditions impact the response of an object acted upon by a set of forces. Consider an object being applied with forces in vertical as well as horizontal directions. As per the parallelogram law of forces, there will be a resultant force and the object will have a translatory motion along the line of action of the resultant. Now assume a frictionless horizontal surface at the bottom of the same object. Under the action of the same set of forces, the vertical load will be supported by the reaction offered by the horizontal surface. As there is no resistance being offered, the horizontal force will be causing a translatory motion. Consider another scenario where the same object is confined to vertical rectangular tube with frictionless internal walls. The vertical tube will be offering resistance to horizontal force. The object is free to move in the vertical direction, and the vertical force will be causing a downward motion of the object. What if both the restraints are simultaneously applied on the object? The applied horizontal load will be absorbed by the vertical tube and an equal and opposite horizontal reaction will be developed. In a similar way, the vertical load on the object will be supported by the flow and a vertical reaction will be developed. With this, the object will be in equilibrium. So, under the action of the same set of forces, resultant motion is varied as per the support conditions. While playing with roller skates, self-weight will be continued to be supported by the horizontal floor. However, as the rollers cannot resist the horizontal force, the man moves forward in the direction of the push. For the analysis of practical problems, support conditions are idealized into different types: roller supports, pin supports, and fixed support. We will review those in detail in a separate video.